We've had a chance to take a look at an example where we don't have to solve for y. Now let's take a look at an example where we do. So this one already looks somewhat messy with negative 2y equal to 2 times the quantity 5 minus 3x. So let's go ahead and start by distributing that 2 to the 5 and to the 3x, so that way we have a little bit more simplified of an expression, which will give us negative 2y equal to 10 minus 6x. Then we can go ahead and divide both sides by negative 2. And in doing so, we get y on the left. And then we will need to butterfly it out. So 10 divided by negative 2 is negative 5. Minus 6x divided by negative 2 is plus 3x. So I'm going to go ahead and rewrite this expression with it in standard form to make it a little bit easier, giving me y equal to 3x minus 5. So I know that my y-intercept is equal to negative 5. So then again, my next step is going to be to go ahead and substitute 0 in for y, which is going to give me 0 equals 3x minus 5. We'll add 5 to both sides, which is going to give me 5 equal to 3x. And then I can divide both sides by 3, giving me an x-intercept of equal to 5/3. I know once again that's a little bit tricky, but we will make it work. So now we can go ahead and we've got a y-intercept of negative 5, so I count down 5 and make my point. I got an x-intercept of 5/3, which is 1 2/3. So I will go ahead and do my best to plot as accurate of a point at 1 2/3 as possible. And then finally I'm going to go ahead and connect my lines, my points to make my line. Alright, now you should know what y equals 5, that y equals 5 is going to be a horizontal line. So what that means is that we already know that this y equals negative 5 is our y-intercept. Because if you recall from earlier, this would be y equals 0x minus 5. Now, if I substitute in 0 for y, I get 0 equals negative 5, which is not a true statement, which is how we know we don't have an x-intercept. And I'm going to write that down so I remember. That makes this one nice and easy to graph. So if we go ahead and put in that negative 5, 1, 2, 3, 4, 5 down, and we know that that's a horizontal line, so I can go ahead and draw my line. Now I am okay with, if you have a horizontal line, only putting one point, because otherwise you can just throw in some random points if you wish. So now we're going to go ahead and take a look at one last example. We have y equals negative 1/2 x. Now if you recall from these types of problems earlier, we don't have any value here, which tells us that our y-intercept is equal to 0. So then if I put in 0 for y, I get 0 equals negative 1/2 x. Well, I can divide both sides by negative 1/2. And one thing we learned last week when we were calculating slope is that 0 divided by anything is 0, which means that x-intercept is 0. And go figure, if our graph is going to cross the y-axis at 0, because that falls at the origin, therefore that also has to be. Now because we don't have any other points to connect some points, I'm going to go ahead and go back to our slope of -1/2 and go down 1 and forward 2, or up 1 and back 2 to create my points that will allow me to graph my line. What you need to do now is go ahead and complete these two problems, y equals -4x plus 1 and y plus 2 equals 5x minus 4, and find the x and y intercepts, graph them, and then you can go ahead and write your summary and bring your questions to class tomorrow.